Hey everyone, welcome back to the Intellectuary channel. Today's video is all going to be about functions, a fundamental part of mathematics, and this is part 1. This is created and presented by Intellectuary, me. So let's start with an intro to functions. Now, what are functions? Well, functions can be defined as a relationship between two variables, in this case, y and x. And there are several types of functions that can be seen in math, and a few examples are shown below. So an example of a linear function would be y equals to 3x plus 4, as it follows the format of y equals to mx plus b. Secondly, we have an example of a quadratic function, 6x squared plus 3x plus 6, which follows the y equals to ax squared plus bx plus c format. And then thirdly, we have an example of an exponential function, y equals to 5 to the power of 3x, which follows the y equals to a to the power of x format. So let's start with linear functions. What are linear functions? Well, linear functions, when graphed on a coordinate plane, are usually represented or graphed as a line. And so the format for any given linear function is y equals to mx plus b, where y is a function of x as y is equal to something, right? M is the slope of the function, x is the variable getting applied by m, and b is the y-intercept, or the starting point of the linear function. And so here are a few examples shown below of linear functions, such as y equals to 3x plus 5 or y equals to 1/2 x plus 7. And if you see on the right, there is a linear graph shown there, which is represented as a line. Now let's try to see if we can determine the linear equation or function based upon the graph shown here. So for this graph shown here, the answer of the equation would be y equals to 1/2 x plus 2. And we use the rise over run method to determine the slope. And so the rise here is 1 and the run here is 2. And so slope is equal to rise over run. So we do slope equals to 1/2, as 1 by 2 is 1/2. And so the y-intercept, or the starting point of the linear function, would be 0, 2. And so the final equation would be y equals to 1/2 x plus 2, as followed in the linear equation format as y equals to mx plus b. So here's a real-world example utilizing linear functions. So a TV subscription has a flat fee of $25 to be able to use their services. For each device that a person streams on, they must pay $5. In part A, they're asking us to create a linear function or equation that models the situation for the total cost of the TV subscription based on the number of devices a person uses. And so our equation would be y equals to 5x plus 25. Here, that for the equation that models the situation. Then for part B, they're asking us to then solve for the total cost of the subscription when a person streams on 2 different devices. So our answer would be to first plug in 2 for the variable x to get the answer. And so we plug in 2 to the equation we got in the previous part A. And then we get $35 as the total cost as our answer. So now let's move on to quadratic functions. So what are quadratic functions? Well, quadratic function is basically a polynomial with its highest exponent or degree being 2. And so quadratic functions, when graphed on the coordinate plane, can be depicted or graphed as, for example, here, we can see the function f of x or y is equal to x squared plus 4. We can see the quadratic function is going up as it has no negative sign in front of the variable x. And in our second example, the function f of x or y is equal to negative x squared plus 4. We can see the function in the shape of u going down as it's negative. So what are the key parts of a quadratic function? Well, firstly, there's a parabola, which is the upwards or downwards u shape the quadratic function makes on the coordinate graph. Then there's the vertex, which is the highest max or the lowest minimum point of a parabola. There's the axis of symmetry, or for shorthand AOS, which is a line that divides a parabola into 2 equal parts, which usually goes through the vertex. And there's the domain, which are all the possible x values or inputs that are able to be plugged into or accepted by a function. And there's the range, which is all the possible y values or outputs of the x values of a function. Then lastly, there are x-intercepts, or our zeros, which are all the possible input values or x values that when plugged in get an output of 0 in a function. So let's see a real-world example utilizing our knowledge of quadratic functions. So here an object is thrown in an upward motion from a height of 25 feet and a velocity of 45 feet per second. This equation that represents the height of the object, h, after t seconds is shown as h is equal to negative 16t squared plus 45t plus 25. And so in part A, they're asking us to find the height h of the object after 2 seconds. And again, the graph of the quadratic function is shown on the right. So our steps to solve for the answer to part A would be first substitute t for the variable t, which is seconds. And so by doing that, we get 51 feet as our answer. And I just want to note a few things on the right side of the slide. So our maximum height here is shown, right, as the vertex, as the function is negative, so it's going down. And so the maximum height would be the vertex here. And then there's also the y-intercept of this function, which should be 0, 25, and it's the starting point of the quadratic function. And there are also 2 zeros down below. So this is a continuation of the question. So in part B, they're asking us to determine the domain of this quadratic function. And our answer would be that the domain of this quadratic function would be all real numbers represented in interval notation, negative infinity, comma infinity. And this is because no matter if a quadratic function is negative or positive, or in other words, going up or going down, the x squared part in the quadratic function is always positive. So this means that any real number can be an input or x value of a quadratic function. Now for part C, they're asking us to determine the range of this quadratic function. And our answer would be that the range would be y is less than or equal to 56 or negative infinity, comma 5. So this range of this function represents all the possible y values or outputs that this function can have. So all the possible y values less than 56 are outputs of this quadratic function. And we can find the range through a variety of methods, like looking at the maximum or minimum point of a graph, looking if the function is increasing or decreasing. So these methods can easily help you determine the range of the function. Thank you guys. I hope you guys learned a great lesson of quadratic functions and linear functions today. And don't forget to like, share, and subscribe for not missing out on any notifications or updates whenever I post a new video. Thank you.